For a little while I've been wondering how much pressure my hot end on my 3D printer generates, so I'm going to do a little experiment and find out. Here's the plan. I'm going to take these 0.4 millimeter diameter nozzles, take this drill bit, it's a 1/16 of an inch in diameter, or I think it's 1.56 millimeters diameter, bore these out with my drill press, then put these in the printer hot end, put this up into the nozzle, and then I'm going to put this onto a scale and see when the filament comes out and presses on this, how much force it's going to generate. And from those numbers I'm going to estimate nozzle pressure. In my hand is the before. You can see the 0.4 millimeter hole. And these are the after being drilled out by that 1/16 inch drill bit. And then the bit goes in the hole. We'll see what happens. Alright, I marked with a Sharpie here so that the end of the drill bit aligns with the end of the nozzle, just as a reference point when I stick the drill bit in. I'm in manual mode, got the scale here, got the drill bit, and gonna give it a shot here. I'm gonna move manually the Z-axis up. And we're right about right. I can see the mark there. Let's see what happens here. I'm going to turn this on. It's going to be zeroed. It's all zeroed. Let's see what happens. I'm going to manually feed on the E here. 10 millimeters. Oh! Okay, I had like a peak of 8.9 there. Yeah, I definitely see the extruder spinning. Okay, it's going around. Alright. We had like a peak of like 8.9 ounces. Now there's some pressure. There's a little bit of pressure on there now. Let's see what happens if I do it again. Another 10 millimeters. Yeah, because it's not a perfect seal. It's not a perfect seal around that drill bit. Here we go, 10. Oh, wow. Holy moly, we had like over a pound there. That was more force than I expected. Now it's kind of all sealed and gooed up around the edges there of that drill bit. Okay, wow. Over a pound and a half on that one. Oh, that's cool. The drill bit's like slowly sliding out. Let's see, I'm gonna lower this again. Pretty neat. Pretty neat. What's kind of neat here is the PLA formed like a seal around the drill bit. Pretty neat. Alright. Here's the feed rate. This cog is marked here on the E-axis. Now to do the same thing on the TEVO Tornado. Let's see what happens here. Alright, let's extrude 10 millimeters. There you go. And we're doing red this time. Same nozzle. PLA 200C. Same test. Got the drill bit in there. Here we go. Extruding. 10 millimeters. Yeah, we got something going on. Alright, let's try another 10. See if it'll build up a little pressure. Same experiment. We're on a Creality Ender 6, and I'm going to feed in filament. Here we go. Doing anything? Oh, it's going. It's going. Oh, actually, we're able to generate quite a bit of force. I hit it twice in a row, though. And all right, it stopped right now. Here we go. Let's try this again. 1, 2, 3. Okay, generating some pretty decent pressure here. And here are the results. To be honest, the pressures and PSI here were higher than I expected. I didn't think they'd be able to get near as high as they did. The Creality Ender 6 almost got to 1,000 PSI. Now, these aren't nearly as high as injection molding typically, which can get between 10,000 and 16,000 PSI in pressure. But, you know, maybe this could be used for some kind of interesting application. I got some new ideas. Yeah, I've just been wondering about this recently, and these are the peaks for the trials, and then the averages, and then the you know, normalized for such a small surface area. It amounts to a pretty good pressure. Alright, well, thank you for watching, and now you know this is an easy test anyone can do at home, and feel free, if you want, to do a test of your own. Post your machine and the pressure generated in the comments.